Okay, so section 111.1, this is about confidence intervals for one population proportion. So we'll discuss how to construct the confidence interval for one population proportion. And mostly we construct confidence interval for population proportion when we have categorical variable. So that's mean the variable is not quantitative variable, when the variable is qualitative variable. Okay, population proportion and sample proportion. So what is the population proportion? So we consider a population in which each member either has or doesn't have a specific or a specified attribute. Then the population proportion P, which is denoted by P, we already know that the population proportion is denoted by P, right? So we already know that. The proportion of the entire population that has the specified attribute. So for example, if we consider a population and we want to know the gender of the population, for example, male or female. So the proportion of the entire population that has a specified attribute is called the population proportion. So what is the sample proportion? Sample proportion is denoted by P hat. So it's actually similar. So for population mean we used mu, and for sample mean we used X bar. But here this is the proportion. So for the population proportion, the notation is P, and for the sample proportion, the notation is P hat. And this is the proportion of a sample from the population that has the specified attribute. Okay, a sample proportion P hat is computed by using the formula. So this is the formula we use to calculate the sample proportion. So where X denotes the number of samples in, number of members in the sample that have the specified attribute. So for example, if we toss a coin 100 times, then we'll get head and tail, right? So each time we'll get either head or tail. So now we want to know that how many times or what is the percentage of getting head. So this is here, if X denotes the number of heads, then the percentage per head will be then P hat is equal X, which is the number of heads, divided by total number of tosses, right? So that's been X over N. So this is the sample proportion of getting number of heads, and this is the percentage of getting number of heads. So where X denotes the number of members in the sample, so X denotes the number of heads. So which is the number of members, right? And N is the total sample size. So we did the toss 100 times. So that's been our sample size is, we have 100 samples. So our sample size is N is equal 100 in this case, right? So for example, out of 100 tosses, if we get 60 heads, then the sample proportion will be P hat will be then 60 over 100. So that's mean it will be 0.6. Okay, so since we'll make inference about the population proportion, so we need to know we need to use a statistic, right? And we need to know the distribution of this statistic. So which is called the sampling distribution. So here to make inference about P, we'll use P hat. So here the statistic is P hat. So in case of mean, the statistic was X bar, right? Because we use X bar as an estimate of mu. But here we'll use P hat as an estimate of P. So that's mean the statistic is P hat here. So we need to know the distribution of P hat. And this is called the sampling distribution of P hat. And P hat is the sample proportion. So it is the sampling distribution of the sample proportion. So for our sample size N, the mean of p hat equals to the population proportion. So that's mean, okay, so to know a distribution or sampling distribution, what do we know first? We need to calculate the mean of that statistic and the standard deviation of that statistic. So for example, to know the distribution of x bar, we calculated mu x bar, right? The mean of x bar, population mean of x bar. We also calculated sigma x bar. So that's been the standard deviation of x bar. Similarly, to know the distribution of p hat, we need to calculate the mu p hat. So that's been the mean of p hat. So which is the population proportion p. And do you have any question? Okay. So if you do not have question, please
Like the only thing is you
turn
have
off
to
your
pay,
microphone.
like $15, and then like what is it like design? I mean, it's not $15, right?
Okay. So the mean of the p hat is p, and we also need to know the standard deviation of p hat. So what is the standard deviation of p hat? So sigma, the notation is sigma p hat, and the variance is p times 1 minus p over n. Okay, so the standard deviation will be then square root of this one. So then sigma p hat will be then square root of p times, sorry, 1 minus p over n. So that will be the standard deviation of p hat. Okay, so it is similar to the distribution of x bar. When n is large, p hat will be approximately normal distribution. Okay, so in case of making inference of population mean, we discussed about one mean G interval procedure. And here, since we are talking about the proportion, so we'll discuss about one proportion Z interval procedure and one proportion Z test. Okay, so the purpose is to find a confidence interval for the population proportion P. So the purpose is we want to construct a confidence interval for P. And to do that, we need some assumptions, and the first assumption is simple random sample. So we had the same assumption for one mean Z interval, right? And the second one is the number of success. So here the number of success is X, and the number of failures is N minus X. For example, if we toss a coin 100 times, and if we want to know the proportion of getting head, then the number of success will be number of heads, right? And which is denoted by X. So number of failures will be, so if N is the total number of observations and X is number of success, then the rest of the outcomes will be number of failures, right? So that's mean N minus X. Okay, the second assumption is the number of success X and number of failures N minus X are both 5 or greater. So X should be greater than equal 5, and N minus X also should be greater than equal 5. So if we have this condition satisfied, then we can use Z interval, one proportion Z interval procedure. Okay, so now I'll discuss about the steps to construct the Z interval. The first step is for a confidence level of 1 minus alpha. So if we want to have confidence level 1 minus alpha, you need to find the critical value, which is Z alpha over 2. Now this is similar actually. This is similar procedure to constructing the confidence interval for the mean. Okay, step 2 is the confidence interval for P is from. So this is the formula you will be using to construct the confidence interval. So how did we get this formula? Okay, so let me show it. Okay, so if you remember the formula for the confidence interval for one population mean, then it was x bar plus minus Z alpha over 2 times sigma over square root of n, where x bar is the estimate of mu. X bar is the estimate of mu, and sigma over x bar, which is the standard deviation of x bar. So that's means sigma x bar was sigma over square root of n. So similarly, for this one, we need the point estimate, which is p hat. So that's mean instead of x bar, now we'll be using p hat plus minus Z alpha over 2, it will be the same, times the standard deviation of p hat. So here we use the standard deviation of x bar. Now we'll use the standard deviation of p hat, which is square root of p times 1 minus p over n. Okay, then it will be square root of p times 1 minus over n. Okay, so now if you know the p, then you will be using p, but what if you do not know the p? In that case, you will be using p hat. So in that case, it will be then p hat plus minus Z alpha over 2 times square root of p hat 1 minus p hat over n. So this is the formula you will be using to construct the confidence interval for p hat. Do you have any question? Okay, so if you do not have any question, then we'll discuss the margin of error. So how do we calculate the margin of error in this case? The formula will be, you will be using this formula. E is equal Z alpha over 2 and the standard error. So that's with the standard deviation of p hat. So in case of mean, we used E is equal Z alpha over 2 sigma over square root of n to calculate the margin of error. But in this case, the standard deviation of p hat is square root of p hat times 1 minus p hat over n. So that's why you will be using this formula to calculate the margin of error. Okay, so now if we want to have a specified margin of error, then what should be the sample size? So to determine the sample size, you have to use this formula, 1 minus alpha level. So if you want to have 1 minus alpha level confidence interval, and you want to have at most the maximum E margin of error. So you want to have this margin of error, maximum of this margin of error. Then what should be the sample size? Okay, so the sample size n is equal 0.25. Okay, so how did we get 0.25? So if you do not know the population proportion, if this is not given, then you will be using 0.25. Actually, the 0.25 came from here, p times 1 minus p. So if the population proportion is not given, then you will consider the population proportion is 0.5. So that's when you will be considering the proportion of success is 0.5 and proportion of failure is also 0.5. So equal proportion. So if you consider P is equal 0.5, then 1 minus P will be also 0.5. So that's been 0.5 times 0.5, which is 0.25. So that's why we have 0.25 here. Okay, the sample size will be that n is equal 0.25 times z alpha over 2 over e squared. Okay, but if you can make a guess of p hat, so that's mean if you can make a guess of the proportion, then you can use that one to calculate this value. So in that case, instead of using 0.5, you will be using your educated guess. So that's mean if you can approximately guess the proportion, then you will be using that value. So this is called p hat subscript z, and this is actually came from guess. So this is your guess. Okay, so after calculating n, if you get a fractional number, then it will be always round up to the nearest whole number or nearest integer. Okay. Okay, so now we'll go over some example. Okay, so given below are the number of successes and sample size for a simple random sample from a population. So the first assumption was simple random sample. So we have this assumption. Now we need to check the x and n minus x. So here x is 12 and n minus x is 50 minus 12. So which is 38. Okay, so both of them are greater than 5. So that's mean we can use z interval. So the both assumptions satisfied. So we can use z interval. So first one is determine the sample proportion. So what is the sample proportion? What is p hat? We know that p hat is equal x over n. So here this is 12 over 50. So now you need to calculate this one, and that will be the sample proportion. So let me calculate this one, 12 over 50. So which is 0.24. Okay, part B is decide whether using one proportion z interval procedure is appropriate. Yeah, we already know that z interval is appropriate because n is 12 and n minus x is 38, and both of them are greater than 5. So if appropriate, so yes, it's appropriate. So part C is use the one proportion z interval procedure to find the confidence interval at the specified confidence level. Okay, so now we need to find the confidence interval. So step 1. So what is the confidence level here? So we want to construct a confidence interval, and confidence level is 95%. So that's mean the 1 minus alpha is 95%. So alpha will be then 5%, which is 0.05. Then you need to calculate z alpha over 2. So which is z 0.025. Okay, then you need to use this formula, p hat plus minus z alpha over 2 times square root of p hat 1 minus p hat over n. So now we have all the information. We have p hat. We can find the 0.025. I think this is 1.96, I guess, but you can find it from the table. So you will plug in all this number, you will plug in p hat, you will plug in z alpha over 2, and you also know this p hat, and you know the sample size n is 50. So you will plug in all the numbers and simplify it. Then after that, you will get these two numbers. For the negative sign, you will get 0.122, and for the plus sign, you will get 0.358. So that's mean we are 95% confident that the population proportion will be between these two numbers, between 0.122 and 0.358. Okay, part D, if appropriate, find the margin of error for the estimate of P and express the confidence interval in terms of the sample proportion and the margin of error. So basically, you will write this value and this value. So that's mean P hat plus minus E. So you will be writing the confidence interval like this. P hat plus minus E for part D. So do you have any question? Okay, so if you do not have any question, then we'll move to the next problem. So for the specified margin of error and confidence level, obtain a sample size that will ensure a margin of error of at most the one specified. So here we want to have margin of error E is equal 0.04. Okay, so to obtain this margin of error, maximum margin of error 0.04, what should be the sample size? So you need to find the n. So here the confidence level is 99%. So 1 minus alpha is 0.99. So alpha will be then 0.01. Okay, so now you need to find n, and n will be then, so here the population proportion is not given, right? So we do not know the population proportion, and we do not have any educated guess. So that's mean we need to use this formula 0.25 we have to use this formula. N is equal 0.25 z alpha over 2 over E squared. So now you need to find z alpha over 2. So that's means z 0.005. I think this is 2.576, but you need to check it. You need to check the z. You need to look at the z table and find the z alpha over 2. I think this is 2.576. So now we'll plug in all the numbers 0.25, and this is 2.576, and the margin of error we want to have 0.04. Okay, then you will get 1036 point something, but you have to always round it up. So that's mean if you round up to the nearest integer, then it will be 1037. So this is the required sample size to obtain 0 point maximum margin of error 0.04. The next problem is during a period of 11 years of 1900 people that were selected for grand jury duty, 24% of them were immigrants. So construct a 99% confidence interval for the percentage of grand jury members who were immigrants. So out of these people, this percentage were immigrants. So now we need to construct the confidence interval for the true proportion. So that's been the population proportion. So we need to construct the confidence interval for P. So here the P hat is 24%. So which is 0.24. Okay, so sample size n is equal 1900. Okay, so before using z interval, you need to check whether this is greater than equal 5 and this is also greater than equal 5. Okay, so now the question is, so what is the value of x? So actually we are interested about the percent of immigrants, right? So that's been here the success is number of immigrants out of 1900 people. So n is 1900. So n minus x will be then, so you need to calculate x. X is actually the percentage of immigrants times the total number of people. So that's been 0.24 times 1900 is the x value. 0.24 times 1900. So 4556. So x is 456. So that's mean this is correct and this is also correct. So we can use the interval. So we know p hat and we know the formula for calculating z interval. So let's calculate the z interval. And the formula is p hat plus minus z alpha over 2 times square root of p hat 1 minus p hat over n. Okay, so we know that p hat is 0.24 and what is the z alpha over 2? This is 99% confidence interval. So alpha is 0.01. So z alpha over 2 will be then 2.576, I guess, but you need to please check this one. So use the z table and check whether it is 2.576 or not. Okay, so then it will be 0.24 plus minus 2.576 times square root of 1900 and 0.24 1 minus 0.24. Okay, so now you need to simplify this one. So after simplifying this one, you will get the confidence interval. Okay, so that's all about constructing confidence interval for one population proportion. So do you have any question? Is it clear how to construct the confidence interval for one population proportion? And when to use the z interval to construct the confidence interval for one population proportion? Do you have any question? Okay, so if you do not have any question, then we'll move to the next section. So this is about hypothesis test for one population proportion. See, you already know the hypothesis test for one population mean, but now we'll do hypothesis test for one population mean, right? You also know two population mean, but you do not know how to perform the hypothesis test for one population proportion. So in this section, we'll discuss about this. So one proportion z test, and the purpose is to perform a hypothesis test for a population proportion P. So assumptions are same, simple random sample, and both n times P0, the hypothesized value. So this is actually x. X means number of success under null. So this is the success under the null hypothesis. And excuse me, n times 1 minus P0, this is actually n minus n times P0, so n minus x. So it should be greater than equal 5, and this one should be also greater than equal 5. So this is actually under the null hypothesis. Okay, so you need to just take n times p0. So you will be given the sample size and you know the hypothesis value p0. So you will multiply the n with the hypothesis value n times p0 if this is greater than equal 5, and you will also multiply n with 1 minus p0. If both of them are greater than equal 5, then you can use the z-test. Otherwise, you cannot use z-test. Z-test is not appropriate in that case. Okay, so next step is decide the significance level alpha. So it's similar actually. So you have to decide the significance level. First, you will write the hypothesis. So previously you wrote the hypothesis in terms of mean. So you wrote mu equal mu0 and mu less than, greater than, or mu less than, or mu not equal. But here we are doing hypothesis test about the proportion. So that's why we're writing P is equal P0, the hypothesis value. And then P less than P0 and P greater than P0. So decide on the significance level alpha. So then you have to decide the significance level alpha. So compute the value of the test statistic. So what is the test statistic? Z observed is equal P hat minus P0 divided by square root of P0 times 1 minus P0 over N. So this is the formula for calculating test statistic. So which is denoted by Z0 or Z observed. Okay, the next thing is if you use the critical value approach, then you will be finding the critical values. Or if you want to use the p-value approach, then you have to find the p-value. So from step 3, you have the test statistic. Now you will calculate the critical value. So you will compare the test statistic with the critical value. So if your test statistic falls in the rejection region, you will reject the null hypothesis. And if it does fall in the non-rejection region, then you will fail to reject the null hypothesis. And for the p-value case, it's also same. If p-value is less than or equal alpha, you will reject the null hypothesis. If p is greater than alpha, you will fail to reject the null hypothesis. And step 6, you have to interpret the results. So this is similar to the hypothesis test for one population mean. Okay, so now we'll go over some example. The first one is the number of success and the sample size for a simple random sample from a population are given below. So we have the number of success. X is equal 7. We have the sample size N is 35. So first part A is determine the sample proportion. So that's when we have to determine P hat, which is X over N. So 7 over 35. So now you need to calculate this one, 7 over 35, and which is 7 divided by 35. So this is 0.2. So this is the sample proportion. Part B, decide whether using the one proportion z-test is appropriate. Okay, so simple random sample. Number 1 is simple random sample. Yes, that's correct. So we used a simple random sample. So this is correct. So now assumption 2 is N times P0. So what is P0 here? The hypothesis value, which is 0.4. So that's been 35 times 0.4. So which is, I think 1.14, which is 14, I think. Okay, so let me check. 35 times 0.4. Yes, this is 14. So that's when this is greater than or equal 5. Then you need to calculate N times 1 minus P0. So that's been 35 times 0.6. 35 times 0.6, which is 21. So this is also greater than equal 5, right? So that's mean this is appropriate. So this is appropriate. Okay, since the Z procedure or Z test is appropriate, so we'll use the Z test to perform the hypothesis test. So how do we perform the hypothesis test? The first thing is step 1, we need to write the hypothesis. So what are the hypotheses here? The null is P is equal 0.4 and alternative is P less than. So the null hypothesis is P is equal 0.4 and alternative is the proportion is less than 0.4. Okay, so here the P0 is 0.4. Okay, so this is left tail test, right? This is left tailed test. Okay, so now the step 2 is we need to decide the alpha value. So what is the level of significance? The level of significance is 10%. The alpha is 0.1. So alpha is 0.10. Then step 3, calculate the test statistics. So which is Z observed, this is equal P hat minus P0 divided by square root of P0 1 minus P0 over N. So this is the formula to calculate the test statistic. So what is P0? P0 is 0.4. So that's means you need to plug in P0. And what is P hat? P hat is 0.2, right? X over N. So we have P hat, which is 0.2 minus P0 is 0.4 and square root of 0.4 times 0.6 over 35. So if you simplify this one, then you will get the test statistic will be the negative 2.42. So the Z observed is negative 2.42. So this is the test statistic. Okay, then step 4, you need to find Z alpha over 2. So alpha is 0.1. So alpha over 2 is 0.05. So Z alpha over 2 will be then Z 0.05, which is the critical value. And in this case, since this is left tail test, the critical value will be negative of this one, right? So negative of this one. Yeah. So, and this is negative 1.28. This is negative 1.28. So this is the critical value. So now step 5, we need to make the decision. So we know draw the normal curve, and this is negative 1.28. And what is our test statistics? Z observed was negative 2.42 or something, right? So we found negative 2.42. 2.42. So where does that test statistic fall? So this is somewhere here. So the test statistic is in the rejection region. So that's mean we reject the null hypothesis. So we reject the null hypothesis in this case. Do you have any question? Okay, so if you do not have any question, then we'll go over one more example. So according to a survey of 850 web users from generation Y, 442 reported using the internet to download music. Okay, so here the sample size is 850 and X is 442 because we are interested how many are using the internet to download music. So part A, determine the sample proportion. So we need to calculate p hat, which is x over n. So that's been 442 over 850. Okay, so if you simplify this one, then it will be 442 divide 850. So this one will be then 0.52. So this is the proportion. Part B, at 10% level of significance. So alpha is 10%, 0.1. So do the data provide sufficient evidence to conclude that a majority of generation Y wave users using the internet to download music? So what does it mean by majority? Majority means the proportion is greater than 0.5, right? So that's mean we want to do a hypothesis test to see whether the true proportion is greater than 0.5 or not, right? So we want to do test this one, p greater than 0.5. So that's mean our, so the step one is write the hypothesis. So you need to write the null and alternative. So the null is the proportion are equal, and alternative is the proportion to proportion is majority, that's been more than 50%. So p is greater than 0.5. So this is right tail test. This is right tail test. Okay, so step two is decide your alpha. So alpha is 10% level of significance. So this is 0.1. Then step three, calculate the test statistic. Z observed, which is p hat minus p0 over square root of p0 times 1 minus p0 over n. So this is the formula to calculate the test statistic. Okay, so now we know the p hat. P hat is 0.52, and we know the p0, which is 0.5, and we know the sample size, which is 850. So now you need to calculate the z observed, which is p hat minus p0 over square root of over n. Okay, so now plug in all the numbers here. So this is 0.52 minus 0.5 and square root of divided by 850. So if you simplify this one, then you will get the test statistic, which is 1.17. So it is 1.17. Okay, so this is the test statistic. Okay, so now you need to, step 4, alpha is 0.1. You need to calculate, since this is right tail test, you need to calculate z alpha over 2. So that's been z 0.05, which is 1.282. Yeah, 1.282. Okay, so we have the test statistic, we have the critical value, we can draw the normal curve, right? We can draw the normal curve. So, okay, no, this is not the, this is the right tail test, right? So this is 1.282. and this is the rejection region. This area is the rejection area or rejection region. So what was our Z observed? So Z observed was 1.17. So 1.17 is somewhere on the left of this one, right? Somewhere here. This is 0. So that's mean the test statistic falls in the non-rejection region. So it doesn't fall in the rejection region. So in this case, we fail to reject the null hypothesis. So in this case, we fail to reject the null. So step 6, interpretation of the results. So how do we interpret the results? So here we wanted to see whether the majority of generation Y web users use the internet to download music. So that's been since we failed to reject the null, so at alpha is equals to 0.1, the data doesn't provide sufficient evidence to conclude the alternative, So what is the alternative here? The alternative is that the majority of generation Y web users use internet to download music. So we do not have enough evidence to conclude that, right? Since we fail to reject the null. Do you have any question? Okay, similarly, when you will be doing the hypothesis test for two-tailed, you have to just calculate the critical value. First, you will write the hypothesis, then you will decide your alpha, you will calculate the test statistic, then you will calculate the critical value. So in case of two-tailed test, you will have two critical values. Then you will compare the critical value and test statistic. If the test statistic falls in the rejection region, you reject the null. And if it doesn't fall in the rejection region, you fail to reject the null. Okay, so we have 22 more minutes. So I think I can also go over section 11.3 so that from next class we can go over the review problems for the final. Okay. And today I'm not going to go over examples for this one, but I'll just give you the basic idea of inferences for two population proportion. So we are done with inference for one population proportion. So for two population proportion, actually you will be comparing the proportion for population 1 and proportion for population 2. Basically, we'll be constructing the confidence interval for this one, and we'll also do hypothesis test for this one, similar to mu1 minus mu2, the mean difference of population 1 and population 2. Okay, the sampling distribution of the difference between two sample proportion for independent samples. So we'll consider independent samples. So for two population mean, we had independent samples and also dependent samples. For dependent samples, we used paired t-test. Okay. So since we'll be comparing the difference of P1 minus P2, so P1 and P2, we need to know the distribution of P1 hat minus P2 hat, because this is the point estimate for P1 minus P2. So you need to know the distribution of this one. The distribution of P1 hat minus P2 hat is the sampling distribution for the difference between two sample proportions. To know the distribution, you need to know the mean of this one. So that's mean you need to know mu P1 hat minus P2 hat. So what is the mean of this one? The mean of this one is just the proportion, the difference of the proportion, P1 minus P2. So now the question is, what is the standard deviation? Standard deviation is sigma P1 hat minus P2 hat is equal square root of P1 1 minus P1 over N1 plus P2 times 1 minus P2 over N2. So this is the standard deviation for P1 hat minus P2 hat. Okay, so the distribution of P1 hat minus P2 hat will be approximately normal distribution for large N1, since we have two samples from two populations. So we have to, both of them, the sample size, both the sample size need to be large sample size. When P1 hat and P minus P2 hat is approximately normal distribution. So if N1 and N2 are large, both of them are large. Large means usually we consider N is greater than or equal 30 if it is large. Okay, so that's mean N1 should be greater than or equal 30. Then N2 also should be greater than or equal 30. Usually it also depends on the problem. So it varies from the problem to problem. Yeah. But usually we consider N is greater than or equal 30 is large. So that's why N1 should be greater than or equal 30, and N2 should be also greater than or equal 30. Okay. The purpose is to perform a hypothesis test to compare two population proportion P1 and P2 hat. Okay, so for example, so for this course, Math 2300, so we have different sections. So for example, we want to compare two sections, the online section and, okay, so if we divide all the classes, all the sections into two populations, one is the sections who is online classes and the section for face-to-face classes. And we want to compare the performance of online classes and the performance of face-to-face classes. And one way is, okay, so one way is we can compare the average score, and another way is, so we want to see how many students received A grade for online classes, the proportion of students who received A grade in online classes, and the proportion of students who received A grade for face-to-face classes, or maybe B or A, and we can say A and B and A and B. Okay, so we want to see the percentage of students for the online classes who received either A or B grade, and the percentage of students who received A or B grade in face-to-face classes. So we want to compare these two percentages to determine like which class performs better, online or face-to-face. Okay. So in this case, we have two populations, all the students who are taking online classes and all the students of Math 2300 who are taking face-to-face classes, right? Okay, so what is the success for first population? Or first, then we'll collect a sample from the first population, and we'll also collect sample from the second population. So, and N1 is the sample size for the first population. So that's when we randomly selected N1 number of students who are taking online classes. And N2 is the sample size for second population. So that's when we randomly selected N2 number of students from the face-to-face classes. So now the number of success, so that's been the number of students who are selected from online classes and received either A or B grade. So that will be the number of success for first sample, which is X1. And similarly, the number of success for the second sample will be X2. Okay, so the assumptions are simple random sample. Yes, we randomly selected the students from online classes and we randomly selected students from face-to-face classes. So that's been the selections are, we are using simple random sample to select the sample. Okay, independent samples. So the selection of students from online classes doesn't depend on the selection of students for face-to-face classes. So that's mean these two samples are independent sample. Okay, third one is we need to see whether X and N1 minus X1 are greater than equal 5 and X2 and N2 minus X2 are also greater than equal 5. So that's mean all of them should be greater than equal 5. X1, N1 minus X1, X2 and N2 minus X2. Okay, so then write the hypothesis. The null hypothesis will be, we are assuming that the proportion or the percentage of students who received A or B for online classes and the percent of students who received either A or B in the face-to-face classes are equal. So in the null, we are assuming they are performing same. So that's mean P1 is equal P2. Now we want to see whether the online classes performs better. If we want to see online classes performs better, that's mean the percentage P1 should be greater than P2. So it will be the right tail test. So if we say that, if we want to see that whether the face-to-face student performs better the online students, then we'll do this test, P1 less than P2. And if we just want to see the difference, we do not want to see which class performs better. We just want to see the difference. Then it will be two-tail test. P1 not equal P2. Okay, then step 2 is decide the level of significance. So you have to decide the level of significance. So that's been how much typo error you want to tolerate, or how much typo error you want to consider. Then compute that test statistic. Excuse me. The Z is equal P1 hat minus P2 hat. That's been the difference of the sample proportion divided by square root of P hat. That's been pooled sample proportion. P subscript P hat. This is pooled sample proportion. So how do we calculate this one? So P1 hat we calculate using this one, X1 minus, X1 over N1. And P2 hat is X2 over N2. But here we'll be using this one, PP hat, which is X1 plus X2 divided by N1 plus N2. So that's been the overall percentage or combined percentage. We'll combine the two samples and then we'll calculate the percentage. That is the PP hat. Okay, then you will be using this formula to calculate the test statistic. So when you have the test statistics, then you will calculate the critical value. And you will compare the test statistic and the critical value. So if the test statistics falls in the rejection region, you reject the null hypothesis. If it is outside the rejection region, you fail to reject the null. And you will also calculate the p-value. So if you want to use the p-value approach, And if P is less than equal alpha, you reject the null. If P is greater than alpha, you fail to reject the null. Then last step is you will interpret the results. Okay, the next one is two proportion Z interval procedure. So this is also similar. The assumptions are same. Simple random sample, independent sample, and x1, n1 minus x1, x2, and n2 minus x2 are all 5 or greater than 5. Then you need to determine the level of significance or confidence level. Confidence level is 1 minus alpha, and level of significance is alpha. Then you will calculate Z alpha over 2. Okay, this is the formula to calculate the confidence interval. The difference of two proportion P1 hat minus P2 hat plus minus the critical value Z alpha over 2 and square root of P1 hat minus 1 minus, sorry, times 1 minus P1 hat divided by N1 plus P2 hat times 1 minus P2 hat divided by N2. Okay. And you will get, for the negative side, you will get a smaller number, the lower limit of the interval, and for plus side, you will get the upper limit of the interval. So that's mean we are 1 minus alpha percent confident that, or 1 minus alpha times 100% confident that the difference between the two population proportion will be between these two numbers, and that is the confidence interval. Okay, so today I'm not going to show you any example for this one, but in the next class, at the beginning of the next class, we'll go over some example where we'll construct the confidence interval for the difference of two population proportion. And after that, we'll go over the review problems for the final.